active transport. David7sciencetheater@gmail.com. You can contact us. Consult. Okay. So active transport. This video is representing a second or third or fourth part of transport in and out of cells. Okay. So the next video will show you residual transport, but we shall talk also about osmosis, or we've talked about it, and passive transport. So we are now talking about active transport. Yeah, David 7 Science Theater. Don't forget to subscribe to our videos, we request, and click the bell for more and better videos that we upload daily. Like, comment, and share. Alright, so active transport. If you can just look at this, this is a complex of a lot of things, okay? But if I can take you through, you can see we have exchange of ions between intracellular fluid and extracellular fluid, which exchange is occurring via the cell membrane by lipid layer, okay, or phospholipid bilayer. So you can see, if we just look at this, we have potassium getting out and proton is entering. So this is a potassium hydrogen pump. Now we have sodium entering, hydrogen getting out. So it takes you to note where is hydrogen going? Where is sodium going? Is it getting into the cell or it is getting out? Potassium, we have a lot of it inside the cell. So many times we will find that it is getting out, okay? Except in times where we have co-transporters, like sodium, potassium co-transporter, that one will be putting sodium inside. Sodium and potassium inside here. So active transport alone can be primary or can be secondary. So if you look at this is passive transport. The potassium, which is too high inside, is getting out. The sodium, which is too high outside, is entering passively by diffusion. Okay, so now we have active transport, which can be primary. As you see, this is primary active, where we have a sodium potassium pump. Okay, that is primary active because it is pumping sodium outside and it is bringing potassium inside. Okay, so as it is doing this, it means it is increasing concentration of potassium inside and reducing concentration of sodium inside, which means it is establishing a negative membrane potential inside the cell. Okay, as you can see here, this negative is established by this primary pump, primary active transport occurring. In secondary, we have co-transport or counter-transport. Counter-transport is mediated by proteins, which you can call antiporters, okay? They transfer two molecules or more in different directions. Now we have co-transport, where the protein, you can call it a symporter or a symport pump, okay? So a symporter is taking sodium and sugar or amino acid inside the cell at once. Sodium, potassium inside at once. Sodium chloride inside at once, okay? So that is a symport carrier. This is an antiport carrier. Okay, so we're going to talk more about this. That was the summary of what is here. This is secondary active transport, counter and transport. Active transport primary is here, where we have the sodium potassium pump, which directly uses ATP. Now, then we have passive transport this side. Okay, so let's talk more about this. So active transport refers to mechanism of transport of substances against their chemical or an electrical gradient. Yeah, so we sometimes call it uphill movement, because you are opposing the gradient which has been established. Okay, and active transport involves expenditure of energy, which is liberated by breakdown of high energy compounds like adenosine triphosphate, called ATP. So energy is required for active transport. It is active because we are spending some energy. Okay, high energy compounds are being hydrolyzed to release phosphate bonds which have energy. And this transport will cater for ionic substances and non-ionic substances. For some ionic substances, you can talk about sodium, potassium, calcium, chlorides, and iodide. And for non-active or for non-ionic substances, we will talk about glucose, amino acids, and urea. These are involved in the active transport, as we shall see along. So the types of active transport are two, which we have primary active transport and secondary active transport. All right. And if we talk about primary active transport, in primary active transport, in this process, the energy is derived directly from the breakdown of ATP or some other energy phosphate compound. Okay, and some of the important pumps involved in primary active, you can talk about sodium potassium pump, which we saw in the first as we started. We can talk about calcium pump. This one also directly uses ATP. Then you can talk about potassium hydrogen pump. Okay, so your duty is to note, where is potassium going? Is it getting out of the cell or it is entering? For the case of potassium hydrogen pump, the potassium is getting out of the cell. But if you talk about sodium potassium pump, here the potassium is being pumped from extracellular fluid into the cells. Okay, and the structure of the sodium pump is here. As you can see, this is a protein. Which protein is having, it is transmembrane protein, okay? And it has two units. But the most important unit here I will talk about is the alpha unit, okay? So the alpha unit is very important for the pump. Also has the beta unit. This is extracellular fluid, intracellular fluid, this is a membrane. So what will happen? The 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 part of alpha unit which is inside a cell, okay, this part you can call it a intrinsic part. This part inside a cell it has three sites majorly. It has sodium binding site which takes three sodium ions, then it has phosphorylation site, and it also has ATP binding site. So it has three major sites inside the cell, and on its outside or outside the cell in extracellular fluid it has major two sites: the potassium binding site, which takes two potassium ions, and also has aben binding site. Okay, so the aben binding site is also found outside the cell. All right, so that is the structure. How does it function? There is an enzyme ATPase, as you can see here. This enzyme ATPase, when it is here, that enzyme will be activated when three sodium ions bind and one ATP molecule bind to their respective sites. So these sodium and ATP are binding in the interior part of the alpha unit of the sodium potassium pump. So the sodium binding and ATP binding, it activates ATPase, and the activated ATPase catalyzes hydrolysis of ATP to ADP. And this will liberate a high energy phosphate bond of energy that causes a conformation change in the carrier protein molecule, which will extrude sodium into ECF. Okay, so ATPase is activated, ATP is broken down. This causes a release of high energy phosphate bond, and this energy is used or causes a conformation change in the carrier protein so that the sodium is gotten out of the cell by this pump. So two potassium ions bind to the receptor. This follows the previous statement that two potassium ions will bind to the receptor site on the extracellular surface of the protein, and dephosphorylation of a subunit occurs, which returns the protein to its previous conformation, so releasing potassium into the cell. Just as you can see here, this is the mechanism of operation of this pump. And now having the potassium being released into the cell and the sodium being pumped out of the cell, okay, because there is re-establishment of the conformation after dephosphorylation. Okay, let's continue. So what are the functions of the sodium potassium pump? One, it controls the volume of the cell. And this is the most important function of this pump, because without it, most of the cells of the body will swell up and burst. Okay, so it regulates the amount of fluid within the cell. And two, it is an electrogenic pump, since it produces a net movement of positive charge out of the cell. That is, free sodium will go out, but we replace them with just 2 potassium, which means there is a positive charge being put out of the cell, thus creating electrical potential across the membrane. And this is the basic requirement in the nerves and muscles to transmit the signals, okay? So it plays an important role in that nerves and in muscles, because it establishes a membrane potential. So now we switch to the calcium pump. Just like the sodium potassium pump, this also operates in the same way, okay? And the difference is just that the carrier protein binds calcium ions rather than sodium and potassium, okay? So in this case, this pump will be pumping calcium ions. And calcium pump helps in maintaining extremely low concentration of calcium in the intracellular fluid. That is about 10,000 times less than that in the ECF, okay? And the potassium hydrogen pump is our third protein we are talking about in active transport, primary. So the primary active transport system of hydrogen ion also operates in the same way, just like the sodium, and it acts through a phase activity. And these are present at the following 2 places in the body. Where do we find the potassium hydrogen pump? One, you'll find it in the parietal cells of the gastric glands, that is the stomach, and you can find it in the renal tubules. Okay, so that's where you can find the potassium hydrogenate phase pump. Let's continue. Now we switch to secondary active transport. If here, in this process, there is deriving of energy, secondarily from the energy which has been stored in the form of ionic concentration differences between the 2 sides of the membrane, created in the first place by primary active transport. So for this transport type to occur, there must be first primary active transport, hydrolysis of ATP, the major point, okay? So ATP is hydrolyzed, membrane concentration change, ionic concentration differs between ECF and ECF, okay? And this provides energy, which is used to transport the second molecule, okay? And at many areas in the body, transport of some other substances coupled with the active transport of sodium. So majorly sodium is what we find in secondary active transport. And this secondary active may be co-transport or sodium counter-transport. All right. So sodium co-transport, in the case of a simple carrier, just as you can see in this diagram here, we are having glucose. Now we can use glucose or we can use amino acid. So the glucose and sodium both are entering into the cell. Okay. So what happens? If you can just see here, the sodium first binds and it is pumped inside with hydrolysis of ATP. Okay, but that pumping inside will be followed by passive uptake of glucose by the same carrier, which we call a simple carrier. Okay, so substances are carried by sodium co-transport will be including glucose, amino acids, chloride, and iodine. Recall when I was talking about the iodine, sodium iodine symporter, that is used for iodine trapping in the thyroid gland, okay, where they are synthesizing thyroid hormones. So this pump also works there. And sodium co-transport of glucose and amino acids majorly occur transport of glucose or amino acids occurs majorly in the intestinal absorption, okay? In the ileum or in the small intestines, absorption of these two will require a symporter, okay, a symport carrier. Now, iodine, we've talked about it, important in iodine trapping. So let's talk about the sodium counter transport. This one requires an antiport carrier. And in this, for example, you can talk about sodium calcium counter transport, which is known to occur almost in all cell membranes with sodium ions moving inside and calcium being pumped out. Okay, this is a sodium calcium counter transport. We have a sodium hydrogen counter transport in the proximal convolutory tubules. Okay, where the sodium ions will be moving into the cell and protons will be pumped out of the cell by the same antiport carrier. Okay, others you can talk about a sodium potassium counter transport system, sodium magnesium counter transport system, calcium magnesium counter transport system, and also the chloride bicarbonate. We see this chloride bicarbonate counter transport system in the red blood cells, okay? The chloride shift, all right, if you can recall, it requires the chloride bicarbonate counter transport system. So don't forget to subscribe to our videos. Yeah, click the bell for more videos which we upload daily. You like our videos, comment down below. I will be seeing your comments, and share our videos to other students or other people to also enjoy the science. Thank you.